This is number 35 on page 130, and this is a situation where we're looking at, we've got two equations in u and v, and notice that these are not in linear form right now, that the u and v's are in the denominators of those fractions. But we have some suggested substitution here. They said let x be 1 over u. So if I look at that 2 over u, we recognize that that's 2 times 1 over u. And this 3 over v is 3 times 1 over v. So I could replace the 1 over u, it says, with an x. So that 2 over u will temporarily become 2 times x, okay, representing 2 times 1 over u. So I can rewrite the first equation as 2 times x minus 3 times, and of course y is going to replace 1 over v, plus 2 equals 0, so I'll just subtract that 2 from both sides. And then the second equation, same thing. So this is going to be 4x plus 3y plus 1 is 0, so equals negative 1. And then it's really simple to solve for these temporary x and y that you've substituted to represent these fractions. So you'll do that, and then remember you have to go back in the long run and solve for the u and the v. So I have the negative 3y and the positive 3y, which is nice right here. So on the left I have 6x equals negative 3. So x equals negative 3/6 or negative 1/2. And I'll plug the negative 1/2 for x back into this equation, the first one. Minus 3y equals negative 2. So this becomes a negative 1. And if I add 1 to both sides, I have negative 3y, oops, that's a 2. I have negative 3y equals negative 1, so y is equal to positive 1/3. Okay, but remember that this is not the ordered pair. I need to go back and find u and v. So as you recall, x is temporarily representing 1 over u. So if x equals negative 1/2, and I replace the x with the 1 over u, it means that 1 over u equals negative 1/2. And this is simple enough to solve because if the numerators are the same of 1, then u must be equal to negative 2 in that denominator. And then here, for y, you see how y is temporarily representing 1 over v. So I'll replace this y with a 1 over v. 1 over v equals 1 over 3. Then, of course, v must equal 3. So the ordered pair, the solution in alphabetical order, uv, is the ordered pair negative 2, positive 3. And when you plug those in for u and v into the original equations, it makes them both true. And that's that.